Hi and welcome back! Today's video dives into climate science because the planet's life depends on natural cycles, just as human societies depend on stable weather. That leads to these questions. Who do countries listen to on climate science? Who provides the climate data governments rely on? And yes, why has climate science so often been ignored or delayed despite decades of warnings and undeniable evidence? Let's go and find out. Climate science, or climatology, studies Earth's long-term weather patterns through interconnected systems, the atmosphere, oceans, land, and ice. Today, this knowledge is assessed globally by the Intergovernmental Panel on Climate Change, the IPCC. But note, the IPCC doesn't produce new research. Its role is to assess thousands of peer-reviewed studies from institutions like NASA and other scientific bodies worldwide. This is the science governments rely on when negotiating climate policy. Climate science didn't begin with modern politics. Its roots go back to the 17th century, with early experiments on gases and the atmosphere. In the 1820s, Joseph Fourier described how the atmosphere traps heat. In the 1850s, Eunice Foote and John Tyndall identified heat-absorbing gases. By the late 19th century, Svante Arrhenius had already calculated how carbon dioxide could warm the planet. So climate science emerged from physics, chemistry, and mathematics long before climate policy existed. So, how reliable has climate science actually become? Climate science today is not based on a single model, a single institution, or a single group of scientists. Instead, it relies on dozens of independent models developed by research centers around the world, often using different assumptions, data sources, and computational approaches. What is striking is that, despite these differences, the models consistently converge on the same core conclusions. The planet is warming, human activity is the dominant driver, and the impacts are systemic and long-lasting. When we compare past projections with what has actually been observed, global temperatures, sea level rise, melting ice, and the frequency of extreme events, we find that most trends have unfolded broadly as predicted. Of course, there are exceptions. Some changes have happened faster than expected, others more slowly, and regional impacts can vary significantly. But these differences concern the pace and the location of change, not the direction. In science, uncertainty does not mean ignorance. When multiple independent models reach the same conclusions, uncertainty narrows and confidence increases. Today, climate science is not just theoretical, it is increasingly confirmed by reality. So, who do countries actually listen to when it comes to climate science? At the global level, the central reference point is the IPCC, not a single research institution, but as a platform that synthesizes the work of thousands of scientists from around the world. The role of the IPCC is not to produce new data, but to assess, integrate and validate existing research, turning a vast body of science into a shared reference for governments. Alongside this, global agencies such as NOAA, NASA and the World Meteorological Organization provide continuous However, climate policy is implemented nationally. Most countries therefore rely on their own scientific institutions to translate global findings into regional and local assessments. This is where fragmentation emerges. Scientific capacity varies significantly between countries. While some have advanced modeling centers and long-term datasets, others, particularly in developing regions, face constraints in funding, infrastructure, and access to data. As a result, the science itself may be global, but the ability to interpret and act on it is uneven. If the science is robust and widely shared, why does policy action still lag behind? The answer lies in the space between scientific knowledge and political decision making. Scientific evidence does not automatically translate into policy. It must be interpreted, prioritized, and integrated into legal, economic, and institutional frameworks. Here, economic capacity plays a central role. Countries with greater resources can invest in mitigation, adaptation, and long-term planning, while others must prioritize immediate social and economic needs. Education also matters, not only in terms of public awareness, but in how scientific information is understood, debated, and valued within institutions. Finally, political decision-making reflects a wide diversity of backgrounds, expertise, and governance traditions. This diversity shapes how climate science is interpreted and how urgently it is acted upon. In this context, delays in climate policy rarely signal uncertainty about the science itself. They more often reflect structural constraints and governance realities. Taken together, the previous slides help explain why progress towards the Paris targets has been so slow. The environmental consequences of climate change are now widely visible and reported almost daily. Yet, despite this growing awareness, patterns of business as usual largely persist. Climate action is not only a scientific or technological challenge, it is a collective coordination problem. Acting early often involves upfront costs, while many of the benefits are shared globally and materialize over time. In this context, hesitation becomes rational. When one country delays, others may question why they should move first, even when economic conditions would allow change. This dynamic reinforces inaction, normalizing delay despite increasing environmental risk. As a result, the gap between climate goals and climate action continues to widen, not because the science is unclear, but because incentives remain misaligned. If delayed action is partly driven by coordination failures, then the global climate architecture has a clear potential role to play. Rather than focusing only on targets, the GCA can help reduce the perceived risks of acting first. Coordinated commitments make early action less costly and less politically exposed. At the same time, it can support countries that are able to move faster, while providing financial, technological, and institutional assistance to those facing stronger economic and social constraints. This is not about treating all countries the same, but about recognizing differentiated capacities within a deeply interdependent global economy. Modern economies do not operate in isolation. Production, trade, energy systems, and supply chains are tightly connected, meaning that climate inaction in one region inevitably affects others. In this sense, effective global coordination is not an act of solidarity, alone, but of shared self-interest. Most of the tools a global climate authority could rely on already exist. They are not hypothetical nor experimental. Institutional coordination, carbon markets, climate finance, technology transfer, and monitoring systems are all in place and have been discussed throughout this series. Carbon markets, for example, can act not only as financial mechanisms but as signals of credibility and long term commitment. Climate finance and technology transfer are equally critical, especially for countries facing structural, economic, and social constraints. Taken together, these instruments show that the main barrier to climate action is not a lack of tools, nor a lack of scientific evidence. It is the difficulty of translating long term collective interest into short term political decisions. In that sense, the challenge facing climate governance is ultimately one of political courage and shared vision. Thank you for watching and for taking the time to reflect on how science, policy, and responsibility intersect. This series explored why climate action matters and why acting together matters even more. Caring for the planet is a shared responsibility. Bye!